Eastern and Riverside students. Today we're going to be talking about VSEPR, which is all about molecular geometry. So make sure the top of your notes has today's date on it and the title VSEPR, Molecular Geometry. So we started to talk about in class how so far we've only been drawing 2D structures. Lewis dot structures are just two-dimensional. But in reality, we need to understand that molecular models, or everything around us, all these compounds floating around, are actually three-dimensional. So we can use VSEPR, or valence shell electron repulsion theory, to help us understand what are these 3D structures and what shape do they take on. So make sure to write down what VSEPR stands for, valence shell electron pair repulsion. And again, this helps us predict the shape since electrons repel. Since electrons around the central atom are constantly repelling each other, just like two magnets that are both the same, like north poles will repel each other. So therefore, electrons are also repelling each other. They don't want to be by each other. So in our molecule, they're going to be as spread out as possible. So our valence shell electron pair repulsion theory helps us to figure out what 3D shape will it take on. So a few important terms. The central atom we've been talking about a lot this year, or over this semester. It's the atom that is bonded to more than one atoms that's in the center of your molecule. Then since you can't always, create a 3D structure, we will be able to draw our shapes in ways, our molecules in ways that we can tell that they're 3D. So thus, wedge lines will stick out of the paper and dashed lines are behind the paper. So wedge lines mean it's sticking out, dash going in, and make sure you have those terms and ideas in your notes to help you out. So we'll be talking about linear, trigonal, planar, bent, trigonal, pyramidal, and tetrahedral molecular geometry shapes. This is an example of a linear shape. It has two atoms on it. This angle right here is 180 degrees. And notice it has no lone pairs. It kind of makes the line. These electrons on, say if this is CO2, the carbons want to be as far away as possible. Next we have trigonal planar. And this one kind of makes a triangle, so it makes sense. And these electrons are as far away as possible. These degrees right here are 120 degrees apart. Next, we look at bent. H2O is an example of this. They have one or two lone pairs of electrons sticking out, and then two atoms that are farther away. And of course, the electrons, the lone pairs of electrons are the electrons that are also causing it to repel from others. And then trigonal pyramidal looks like a pyramid, so it kind of makes sense, the name. NH3 would be an example of this, where you would have three atoms and then one lone pair sticking out. And we will look at these shapes with your teacher's molecular geometry kits in class. And then tetrahedral makes sense as well. We have four atoms that are as spread out as possible. So how do we create this molecular geometry shapes? We have 5 steps. So pause the video and write down these 5 steps in your notes. Great, now that you have written down those 5 steps, we are going to do some example problems. So our first step said to draw the Lewis dot structure. So you guys have had lots of practice at this now. If you still are confused on Lewis dot structures, make sure you attend office hours or email your teacher for help, because we're going to continue to use Lewis dot structures, so it's really important that we know how to do them. So we're going to look at H2O first. This, if I did all my steps for drawing the Lewis dot structure, this is what I would get for H2O. Next, I count how many electron domains I have. So, according to the video that you should have watched for last class, you have 1, 2, 3, 4 electron domains around it. Next, I'm going to figure out, okay, which of these are bonding and which are non-bonding? Well, those names kind of give themselves away. Bonding are electrons that helping two atoms stay together via a single or a double bond. So we have 1, 2 bonding domains there. So I'm going to put a B by them to remind myself. And then I have 2 non-bonding, and I'm going to put an NB by each of those to represent that. So then I have 2 non-bonding and 2 bonding. SIP number 5 says to look at the chart to determine the molecular geometry. Well, I need to find where on the chart do I have 4 electron domains? Right here. Next, I need to find how many bonding domains do I have? 2. How many lone pair electrons? 2 as well. So thus, the electron domain, or the electron geometry, is tetrahedral, and then more specifically, the molecular 3D geometry is bent. Make sure that you have shown these 5 steps in your notes. Take a second, look at your notes. Do you have the Lewis dot structure drawn? Do you have all the bonding and non-bonding circled and labeled? Do you have the number of electron domains, the number of bonding domains, non-bonding domains? And then did you tell us what the molecular geometry is? Next, we can sketch it out. So notice there's a little sketch right here, or here is a little bit better of a sketch. Sketch out H2O to show us that you know now what it looks like from a 3D perspective. Make sure that this example is filled out thoroughly, and then we're going to do another one. Next, we have CH4. So, of course, the Lewis dot structure looks like that for CH4 if I followed all my steps. This one has 4 electron domains. And all 4 of those happen to be bonding because they are connected to another atom. So I'm going to label B by all of them. Make sure yours are labeled B as well. No non-bonding because we don't have any lone pair electrons. So then I take a look at my VSEPR summary chart. One thing I forgot to mention before is you do not need to memorize this. This chart will always be given to you in general chemistry class. It is given to you just like you can always use the periodic table of elements on tests, quizzes, homeworks. So make sure you use this resource. So I said that I have 4 electron domains. So 4 electron domains is going to make me look somewhere over there. Then 4 of them are bonding, none are non-bonding. So thus it's tetrahedral. So make sure to write